to the PACE Academy. So here in today's session we will discuss about the solutions. So in our daily life we come across in many situations the word solutions like sugar solution, salt solution, HCl solution, NaOH solution, like this. But what is mean by solution, and to which type of mixtures generally we are using this word solutions, and what are the main components of this, how to find how much of that component present in another component, that is called concentration, and how to identify the concentration or how to find the concentration of a solution, what are the different ways to express the concentration. Okay, so all these are going to discuss in this chapter, solutions. Mainly from this topic we will get numericals. Okay, so until and unless we understand this concept we can't do that numericals. So that's why here we have to concentrate more on this topic. Okay, concept. So here just try to understand the concept of these solutions. First, here in this session we will discuss the brief introduction of solutions. In our daily life we come across many substances like this. Here what we are doing, we are adding some salt to the water, right? So that gives us solution. And here we are boiling some compound, it is look like sugar solution, right? Here we are boiling sugar solution, and here it is sky and the plants, here we are observing the air. Okay, next toothpaste and injection syringe, and here it is musical instrument. So if we look at all these are different type of components. Most of the substances are in this, most of the substances are mixtures containing two or more pure substances. So the mixtures are containing one or more type of pure substances. Can you guess which of these are solutions? Here there are three pictures in this which are called solutions. First one, sugar solution, as name indicating it is the solution. Okay, so this first one is the solution. Next look at the second one, brass. Is this solution? Brass, it is in the solid form, is this called solution? Next, here air. Is this air called solution? Again question mark. So here if when we look at these three substances, everyone blindly can say that this is the solution, right? Why? Because we are generally using the word sugar solution, sugar solution. So that's why. So here when sugar mixed in water we will get sugar solution, and that is in the liquid form. So not only sugar solution, if you take the salt solution, when salt mixed in water we will get salt solution, right? And when we add HCl to the water we will get HCl solution, NaOH solution. So here in all these what is the common? Water is common. So we are adding something to the water and we are getting the solution. And one more point here, all these are in liquid state here, but when we look at the brass, it is also a mixture of two or more components, and here air is also the mixture of two or more components, but here the physical state of these two components is different. This is in solid state, this is in gaseous state. So here we may get doubt that these two components are called whether solutions or not. So don't confuse here, these two are also solutions. So here all the three are the examples of solutions. Okay, like sugar solution, brass and air, all these are the solutions. Next, what is solution? What are the solutions? The homogeneous mixture of two or more than two components is called solution. Solution is a homogeneous mixture. If we look at the mixtures, mixtures are how many types? Two types. What are those? Homogeneous and heterogeneous. What is meant by homo and what is meant by hetero? So here homo means same. Homo means same. So here if the composition is same everywhere throughout the solution, that is called homogeneous mixture. Throughout the mixture, if the composition is same, that is called homogeneous. If the composition is different from one area to another, then that is called heterogeneous mixtures. Homo means same, hetero means different. Okay, so homogeneous and heterogeneous mixtures. In this homogeneous mixture of two or more components is called solution. Two or more than two components is called solution. Okay, so solution is mainly homogeneous mixture of two or more than two components. For example, if you take sugar solution, sugar solution. So in this what we are taking? Sugar and water. In sugar solution what we are taking? Sugar and water. That means two components. Okay, so when two components mixed and gives homogeneous mixture, that is called solution. Next, for example, if you take lemonade, in that lemonade what we are taking? First we are taking water and we are adding some lemon drops, then sugar, salt for the taste, right? So here now in that lemonade what we are taking? First water, then sugar, salt and lemon drops. So here we are adding three components to the water. That means that is the homogeneous mixture and that is of more than two components. So that is also called solution. Okay, so solution is the homogeneous mixture of two or more than two components. Okay, next, so what is meant by homogeneous mixture? Here each component may be solid, liquid or gaseous state. So here we will discuss this point later. First, what is meant by homogeneous mixture? What is homogeneous mixture? Homogeneous mixture is a mixture which has same composition throughout the mixture. Okay, so composition and physical properties are uniform throughout the mixture. For example, take a spoon of sugar and mix thoroughly in a glass of water. Okay, take a spoon of sugar and mix thoroughly in a glass of water. Then check whether the taste of every drop is same or not. So here now after mixing that sugar in the water, now you take some sugar solution here and taste it, and take some sugar solution here and taste it, and you take some here and taste it, and check whether the taste of every drop is same or not. So what you will observe here? The taste of sugar solution, not only here, if you take from here also, the taste will be same. Why? Because the composition is same throughout the mixture. Okay, so the amount of sugar particles in the water is same everywhere. It is uniformly spreading. So that's why it has uniform composition, and the physical properties are also same. Physical properties means like melting points, boiling points, physical state and the density, like this. Okay, all these properties are also uniform. If you take the solution here and if you find out the melting point and you take some sample here and check the melting point, so wherever you take the sample, the melting point, boiling points like properties will be same. Okay, so what is homogeneous mixture? Homogeneous mixture is a mixture which has composition and physical properties are uniform throughout the mixture. Okay, so here for example salt solution, not only salt solution, even you can take the salt also. If you mix the salt in the water, we will get salt solution. In that salt solution also the composition and physical properties will be same throughout the mixture. Okay, next, sugar solution. Next, solution is a mixture of solvent and solute. And here we discussed one more point here. What is that? Here each component may be solid, liquid or gaseous state. For example, if you take the sugar solution, so in that what we are taking, we have taken here water and we are adding salt or sugar. So here what is the physical state of water? Liquid. Okay, so it is in liquid state. Next, what is the physical state of salt? It is in solid state. So here each component may be solid or liquid. And for example, if you take the soda, so here when you open the cap of that soda bottle, what you will observe? You will hear the hiss sound, right? So from where you are getting that sound? The gas is coming out from that solution. That means, so here that drink contains gas in that water. Okay, so what is that gas? We all know that is carbon dioxide gas. So what is that? Carbon dioxide. Even if you observe some cool drinks like Sprite, that is also contains carbon dioxide in that. That is called carbonated water. So carbonated water contains carbon dioxide gas in that. So here that is also called solution. In that solution, one component is in gaseous state. So the solution contains components in it, 2 or more components in it. That components may be gas, solid or liquid. Okay, so each component may be solid, liquid or gas. And what is solution here? Solution is a homogeneous mixture of 2 or more than 2 components. So that components may be solid or liquid or gaseous state. Okay, next we learned the homogeneous mixture. Homogeneous mixture is a mixture which contains the composition and physical properties uniform throughout the mixture. Next, we have observed the sugar solution, and if you take the salt solution also, it contains uniform composition and physical properties. Next one, solution is a mixture of solute and solvent. So what we learned here, solutions are the homogeneous mixtures of 2 or more than 2 components, right? In that components, one is called solvent and the other one is called solute. Okay, so here solution is a mixture of 2 components. What are those? Solute and solvent. So here which is called solute, which is called solvent? Solute means the component which is in smaller quantity. Okay, solute means the component which is in smaller quantity. Next, solvent. Solvent means the component which is in greater amount or greater quantity is called solvent. If there are more than 2 components, then if there is only 2 components, we can say that the smaller component is called solute and the greater component is solvent. Then if the solution contains more than 2 components, the one which is in greater quantity considered as solvent and all the remaining components are called solutes. Okay, don't bother how many they are. All other called solutes only. For example, lemonade. Here in that we are taking water in the large quantity, right? So water is the solvent and whatever you are adding to that water are called solutes, like salt, sugar, lemon juice. We are adding lemon juice to the water, right? So even that lemon juice is also called solute. Lemon juice, salt and sugar, and if you add something else to further taste, those are also called solutes. Why? Because all these are in smaller quantity compared to water. So that's why here water is the solvent and all the remaining are solutes. Okay.